So hello everyone, welcome back, and I hope you guys are doing well. So today we are going to solve another LeetCode contest, and this one is weekly contest 490. And this contest is also easy. I don't know what is happening, but some of the contests from the previous days are coming to be very easy, not too much difficult. And the today contest is also like not that much difficult. So without wasting time, let's get started. So let's start with the first question. The first question is marked as medium, but it is not a medium problem, right? It is just there is just little bit difficulty of understanding of the problem, not that much, but if you are reading the problem and if you know how to deal with, then it is become really easy for you as well. So let's understand the problem. You are given an integer array nums, where nums I represent the points scored in the ith game. There are exactly two players. Initially, the first player is active and the second player is inactive. The following rules are applied sequentially for each game. If nums of I is odd, the active and inactive players swap roles. Okay. In every sixth game, that is game indices. Okay. The active and the inactive players swap roles. The active player plays the ith game and gain nums I points. Return the score difference defined as the first player total score and minus the second player total score. Okay. So let's see the first example. Our array is 1 2 3. This is the initial state of our array, and what we have to do, we just have two player. Since the points are odd, the second player become active and gain 1 point. Okay. No swap occurs, the second player gain. Okay. Since the points are odd, the first player becomes active and gain the point. Okay, let's understand it within here for better clarity, like what is actually going on. So what the problem is saying is, we have two players, right? Let's say player A and B, and initially what is the second player is inactive, but the first player is active, right? So we have two players. First player is active and another is inactive, and this array is represent the points in the games, right? So what we have to do, we just have to process, or we have to play this game sequentially. And initially what we have to do, if you see the problem, like they are saying that there are exactly two players, the following rules apply sequentially for each game. We just have to find like how many points is actually acquired by which player, and we just have to return the difference of them, right? So what we have to do, like initially we have just understand we have two players. Initially the first player is active and the second player is inactive, and and we also have two operations in which the state of the player is going to change. State of the players are going to change if the points are odd. In that case, active player become inactive, and vice versa, right? So this is what I have to do. For first point is this, and the second, if the indices, like if it's a sixth game, then also this is also going to be this is also going to be swap the state of the players. Active become inactive and vice versa. So these are the two operation you can say, in which the state of the player are going to be changed. Initially player A is active. If there is no swap, then player A got the point. If there is a swap, then player B got the point, and vice versa. So let's see the first example. Let's write the score of A and score of B. So initially you see the first number, which is 1, which is use this one. The first is 1, which is odd. Then what happen is the score is going to be added to the second of the player, right? Because if you see, we have this particular case, right? If points is odd, active become inactive, which means the second player become active and take the point, which means the second player have the point as 1, right? And the first player is inactive because we perform the swap. Then we move to 2. In this case there is no swap, then again the point is going to be added to the second player, so this is going to be 2, right? And then we move to 3. So 3 is odd. You see, we have a case of this one, if points are odd, active become inactive and vice versa. So right now our first player is inactive and second player is active, so the state becoming to be opposite. First player become active and second player become inactive, which means the first player is going to take the point. So the first player is going to take the point as 3, right? So total points of first player is 3 and the total points of second player is 3, and we just have to return the difference of all the total score of both of the player, right? So this is the first case. Let's see how we can think of the second case, right? So this is the second example, right? So right over here, a is initially 0 and b is also initially 0. First player is active and the second player is inactive. You see, we are at first we process 2, which means 2 is neither satisfy this condition or nor this condition, which means the point is going to be added to the first player, right? So first player gained 2 points. Then we move to 4. You see, 4 is also not satisfy any of the condition, so this is also going to add to the first player, so 4. Then if we move to 2, this is also going to add to the first player, so this is going to 2. But when we reach 1, then in that case 1 is odd, which means we satisfy this particular condition, that, right? So in this case the states of both the players are going to be both of the players states going to be interchanged or swapped, so which means the point is taken by the second player because second player become active and the first player become inactive. Then we move to 2, which is not a odd number and not satisfy the second condition, right? So the second player is going to take that value as well, so which is sorry for that, yes, 1 plus 2, right? And let's move to 6. Now we have a 1 is odd, which means what we have to do, we just have to swap the state of the player, which means the player b second player become inactive and first player become active, right? But make sure there is one more thing to notice, is that if I write the indices 0 1 2 3 0 1 2 3 4 and 5, if you see we are at 5th, which is we are at 6th index, which means we satisfy the first condition but we also satisfy the second condition as well. The sixth game is, in sixth game we also have to interchange the condition, right? So initially what happened when we got 1, b become inactive and a become active, but when we see that this one is the sixth game, then again the roles are swapped, which means b will become active and a become inactive. Then we add 1 to the bth student, right? The player. So this is the initial, this is the final state of our, we can say, player values, and we just have to return the difference of them. So this is quite easy problem. We just have to like play around with the values and the states, and nothing more difficult and nothing more complicated. So you see the code, I just have taken a 2 variables, first to score the score of the first and the second to score the second score of the second. Then I have variable as is active, which helping me to which allow me to add the score at which particular player. I'm just checking both of the condition, that if it is odd, then I'm just changing the state. If it is a sixth game, then I'm also changing the state, and after that I'm just checking if it's active, then I'm storing it inside the first. If it is inactive, I'm storing it inside the second, and just returning the difference of both of them. So this is it, the code. This is pretty easy, and you can just comment down the time and the space complexity of this particular program. This is not medium problem, it is an easy problem, right? So this is it about the first problem. Let's move to the second problem. So the second problem is this is also easy, right? Not difficult, not medium problem. You are given an integer array n. A number is called digitorial if the sum of the factorial of its digits is equal to the number itself. Okay, determine whether any permutation of n including the original order forms a digitorial number. Return true if such permutation exists, otherwise return false. Okay, which means just see, we have a number as 145. We calculated the factorial of all the digits and the number become 145. Thus the answer is 2. Quite straightforward, which means let's take it as, so we have value n, right, and our number is called digitorial if the factorial of each digit is equal to the original number. So this is what we have to achieve, right? So what, and if, for example, if we calculate the factorial of 1 plus factorial of 4 plus factorial of 5, which is giving us as 145, right? So which is the actual number, so this is true, right? And what if our number is not like that, our number is 151 4, right? In this case, the sum of the digit of this factorial is going to 145, but this is not equal to 154, but it is but we can form this by taking the permutation of that number, which means 145 is coming as answer, so we can make a permutation of, so 154 is also a valid answer for this case, right? So this is what they are mentioning over here, that this is the part, determine whether any permutation of n including the original order form or the total number as well or not, right? So this is what I did over here, that if it is not, then I'm just checking if there is any permutation of that number which forms me the result, so I will use that as well, my answer as well. So how to actually achieve it, right? So first thing, you simply know that for we can solve this in a step 1. First we calculate the sum of factorial of digits, right? Step 2, when we get this, we just check if they are equal. Based on the condition, we just simply return true or false, return true if they are equal. If it is not, then we try to find the permutation. And how we can find the permutation? So instead of finding all the possible permutation, we have a better approach to solve this, right? So here we are actually dealing with digits, right? So if you have 154, but the sum is became 145, so how you can actually check if these two numbers are equal or not based on their digit? So instead of finding all the permutation, don't you think we can use their frequencies to actually come up with the solutions? So, and you also know that we are actually dealing with digit, so our digit is also going from 0 to 9, so we don't have to take a much bigger data structure to store their frequencies. So in order to do this, I have a really good approach. We can take an array of 9 length, right? Let's create an array of 9 length, and what we can do, we just have to okay, take it as it is as for now, and just write the indexes 0 1 2 3 4 5 6 and 7, right? So what we can do first, this let's say this is the original number, right? Write it over here. The original is 154 and the sum of factorial is 145, right? So what we can do first, iterate over the sum and fill this array. When we iterate 145, then the value of 5 become 1, right? Value of 4 become 1, how to write it over here, right? And value of 1 become don't know why it is not working, right? So the value of 1 become 1. So this is the initial state of our array, which we fill with the help of some of the factorial of the digits, right? And now what we have to do, we just have to do the same thing for original number. Let's say we are finding the digit of 154. So first we got 4, so we have 4 over here, so this we just simply remove the occurrence of 4, then we get 5, then we remove 5, then we go 1, and after that we just have to check the state of the array. If the state of the array become empty, which means both our number are the permutation of each other, which means it is a part of our answer. If it is not, then we simply return false. So this is what we have to do over here. So let's see the code. So you see, first I'm calculating the factorial and doing the summation of those number. I'm just checking if they are equal, then return true. If it is not, then we try to check if the permutation are equal or not. Then I just created an array of size 10 because the digits are going to be from 0 to 9. And after that I'm just iterating over all the digits of sum and filling my array and doing the same stuff for the original number and just subtracting the value. And I am checking if maybe the number is less than 0 or greater than 1. If it is the case, which means it is not the permutation, I'm returning a false. If it is not the case, which means a given number is a permutation, right? So this is what the code is look like. And yeah, so talking about the time complexity, which is of, you can say, log n, you can say log n multiply n, which is not too much. So yeah, time complexity is log of n, which we are doing for the this part, and 9 of 9 for the 9 size of array. And this is the factorial which we are calculating of the digits we are calculating, which is also of 9, right? So of 9, so which is going to be of log n. This is the time complexity, and the space complexity is of 1 because the size of the array is 9, which is a constant. So this is the piece of code, and the problem is pretty easy. You just need to understand the problem, what they are asking, and how to come up with a solution. So this is the second problem. Let's move to the third one. Third problem is, I would say, quite easy than expected. This is the first, like for the first time I'm solving a easy problem, the third part. So yeah, pretty easy problem. Maximum bitwise XOR after rearrangement. You are given a two binary string s and t of each length, and you may rearrange the character of t in any order, but s must remain unchanged. Return the binary string of length and representing the maximum integer value obtained by taking the bitwise XOR and of s and rearrange t. This is quite easy, right? One optimal rearrangement of. So let's take it over here. So we have two string. What we have to do, we just have to take this XOR and make sure to know the property of XOR. If both are 1, then the value is also going to, then value becomes 0, or vice versa. If both are how to write it over here instead of doing this. If both are 1, then answer is 0, and if both are 0, then answer is also 0. If both are different, either 1 or 0, then answer is 1. So this is the property of XOR which we have to use over here. So you don't need to do a lot of stuff. Make sure you just have to follow this, like you have to maximize, right? So you will try to find the 1 as well, like you try to find the value of 1. So what we can do, if you got 1, you just need to check from somewhere that t contained 0 or not, because if you got 0, then 1 and 0 make a 1, which is going to be maximum. And same stuff for the 0 you have to do. If you got a 0, then you just have to check if there is a 1. If it is, then it's going to give you a maximum answer. So in order to solve this problem in a much quick way, you can, what you can do, store the frequencies of the teeth character, right? And while you're iterating, let's say I'm creating an answer, right? So let's take, this is my answer. I am at 1. First I got 1. I'm just checking inside my data structure that 0 is exist or not. Yes, 0 exists. Then they both are going to come and create an answer as answer of 1. So my string contain 1s. Then I use 0. Then I just simply remove it from here, right? Then I move to 0. Then I again ask the same question. If I have 1, yes we have, then we simply go which, because we have 1 and 0, thus this also going to give me an answer of 1, right? So this is the answer. And then I simply remove the frequency of 1 as well. Then right now I only have 1, and after that I am at 1. I'm just checking if there is a 0. If there is not, which means I need to compromise and I need to use the whatever the character I have left. Then I use 1, and then 1, if you know the similar bit gives you 0, then it becomes 0. So this is the final state of my string look like. And if you see, this is the answer, right? So this is what we have to achieve, a simple simulation, you can say. I just created an array which is also going to be like two size array. You can also take an arrow as well. I'm just counting the teeth character values and the frequency, and I'm just checking the same stuff. Like I'm just checking which character is required right now, right? If my current character is 1, then I'm looking for 0. If it is 0, I'm looking for 1. I'm just checking inside the map if map contain, if it is, then it is going to give me the answer of 1, and I'm just removing the frequency. If map doesn't contain, then I need to compromise and I need to use 0 over here, and after that I just need to remove the frequency of that, because required is something else and we put something else, so we just change with the help of this particular logic, and after that just removing the frequency of that as well, and in the end returning the result. So the time complexity is O of n and the space complexity is O of 1. So yeah, so this is about the third problem. This is pretty easy. Both are like, all the problems are really easy, and the contests are also going to be easy. The contests are not that much difficult, and so this is it about the problems, and this is it about the solution. Let me know in the comment section what you are thought about my explanation, or I need more improvement while explaining, right? That will give me a feedback of, okay, where should I improve. And this is about the problem, and if you are not able to solve, don't get demotivated. If you are, it is just your initial state, you will definitely able to solve problem in upcoming days. So be practicing on a daily basis. And this is it for the video, and I hope you like the video. If you like, let me know in the comment section. Like the video, subscribe to the channel for upcoming videos, and bye bye, take care.